Hello everyone, and welcome back to another video about IB Math Grade 9. In this video, we're going to start a new unit about linear functions. But before we start anything for this unit, I want to do a quick recap just for this first video about past knowledge that you should know before we talk about anything new in this unit. Okay, so there are four things I want to talk about for our recap. The first three are all related, and the fourth one is also something you probably are familiar with, but maybe you forgot. Okay, so let's begin. The first thing I want to talk about is the Cartesian plane. And the Cartesian plane is basically what you see when you see a graph paper. So even in my video right now, I have set up the screen to look like a Cartesian plane. So all these little squares, they're called cells, and this is what a Cartesian plane looks like. It's made of all these little squares. Now we use this to graph our lines, and it helps us a lot because it takes us to the next point. When we are drawing any line, and by the way, linear functions, the word linear, it just means straight lines. Okay, so when we're drawing straight lines, it helps us a lot when we're using a Cartesian plane, because we draw our x and y axes on a Cartesian plane, and then the little squares help us divide all the distances into equal numbers, into equal distances. So we always use x and y axes. The y axis is the vertical line, and the x-axis is the horizontal line. They both meet in a point here where they both have the value of 0, and the y-axis continues downwards also, and the x-axis continues to the left side. In those directions, we go into negative numbers. Okay? The third thing is now we're going to start plotting points. And points also have another name, which is coordinates. So think of coordinates as locations on our x and y axis. So points look like this. When we write them down, they always are between brackets, and then we write the x number first, the x location first, and then the y location. So for example, let's say I want to plot the point 2, 3. That means I would go 2 steps from the 0 point, 2 steps here forward on the x-axis, and then go 3 steps up on the y-axis, and this would be my point 2, 3. If I plot another point, let's say -2, -3, then I would do the same thing but in the other direction. So again, starting from 0, 0, I'd go 2 steps backwards and then 3 steps down, and this would be -2, -3. And then everything we're going to do in this unit will be about the lines that we can make, the straight lines we can make when we plot points on the x and y axes. Okay, and then how to write these lines in equations. But let's not get ahead of ourselves. The last thing I want to talk about in this video is the Pythagoras Theorem. So the Pythagoras Theorem always dealt with, or it was related to, right angle triangles. Okay, like this one I drew right here. And in right angle triangles, it means there's one angle always that is 90 degrees. Okay, and then the side of the triangle that is opposite that angle, so in this case, this side here, do you remember what it was called? It was called the hypotenuse. And this side is always the longest side in the right angle triangle. Okay, so the Pythagoras theorem helped us get any side of a right angle triangle that we're missing if we have the two other sides. And the rule was, let's call the other sides A and B, okay? So let's say this is side A, side B, and then in general we call the hypotenuse H, but I called it L in this case. So the rule is that the square of the hypotenuse is equal to the square of the first side added to the square of the second side. So H squared equals A squared plus B squared. And then if we want to get the hypotenuse itself, that means we need to do a square root. So H would be the square root of A squared plus B squared. So let's use this example right here. We have a triangle, a right angle triangle. One side is 3 centimeters, the other side is 4 centimeters, and we need to find L. So in this case, L would be equal to the square root of 3 squared plus 4 squared. Now 3 squared is 9 and 4 squared is 16. That means L equals to the square root of 9 plus 16 is 25. And the square root of 25 equals 5. So L here is 5 centimeters. Okay, this is all the recap I want to do before we start the unit. Hope it helped you remember some of the previous stuff you learned. And yeah, I'll see you in the next video.